Hey everyone, Linus here. Please subscribe to this channel. Today we're diving into the world of adders. What is an adder? These little guys are the unsung heroes of computers. They're the reason we can do all sorts of cool stuff, from gaming to video editing to browsing the web. So, what exactly is an adder? Simply put, it's a digital circuit. And what does it do? It adds numbers. Now you might be thinking, big deal, my calculator can do that, and you'd be right. But here's the thing. Computers don't think like calculators. They use binary code, which is a fancy way of saying they only understand ones and zeros. Adders bridge the gap between our decimal system and the binary language of computers. Think of adders as the tiny calculators inside your computer. They're working tirelessly behind the scenes, crunching numbers at lightning speed. Without them, your computer would be about as useful as a brick. No spreadsheets, no games, no YouTube. The horror. So next time you're playing a game or watching a high-definition video, remember the humble adder. It might be small, but it's an essential part of the digital world we know and love. How do adders add numbers with only ones and zeros? It's all about binary addition. In binary, we have two digits, 1 and 0. 1 plus 0 equals 1, 1 plus 1 equals 10. In binary, 10 represents 2. The left digit is the carryover, like adding 9 plus 1 in decimal. Binary addition works similarly. Adders use logic gates for calculations. Logic gates are tiny switches for electrical signals. Combining gates creates circuits for binary addition. Like Lego bricks, gates build complex circuits. Now let's talk about the stars of the show, half adders and full adders. These are the fundamental building blocks of more complex adders. Let's start with the half adder, the simpler of the two. Imagine you have two single-digit binary numbers to add. That's where the half adder comes in. It takes two inputs, A and B, which can be either 0 or 1. It then spits out two outputs, the sum, S, and the carryover, C. Remember our binary addition rules. 0 plus 0 equals 0, 1 plus 0 equals 1, 0 plus 1 equals 1, and 1 plus 1 equals 10 with the carryover. The half adder follows these rules precisely. It uses two logic gates, an XOR gate and an AND gate. Don't worry too much about the technical jargon. Just know that the XOR gate gives you the sum output, S, while the AND gate handles the carryover, C. However, there's a catch. The half adder can only handle two inputs at a time. What happens when we need to add bigger numbers with multiple digits and carryovers from previous additions? That's where the full adder steps in to save the day. Full adders handling the carryover. The full adder is like the bigger, more capable sibling of the half adder. It can handle not only the two input bits A and B, but also the carryover sin from a previous addition. This makes it perfect for adding multi-digit binary numbers. The full adder has three inputs, A, B, and sin. And just like the half adder, it outputs the sum, S, and the carryover, count. The magic of the full adder lies in its ability to handle the carry-in, allowing us to chain adders together for more complex calculations. Internally, a full adder is actually built using two half adders and an OR gate. It's like combining two smaller Lego creations to build a larger, more impressive structure. The first half adder handles the A and B inputs. Then the second half adder takes the sum from the first adder and adds it to the carry-in, sin. Finally, the OR gate combines the carryouts from both half adders to produce the final carryout, count. So, while the half adder is great for basic additions, the full adder is essential for any serious number crunching. It's the workhorse of modern computers, handling the bulk of arithmetic operations. Adder types, from ripple to carry select. Not all adders are created equal. Different types of adders have unique strengths and weaknesses. The ripple carry adder is like an old pickup truck, simple but slow. Carry look-ahead adders are faster, calculating carryouts in parallel. Imagine multiple lanes on a highway. Carry skip adders take shortcuts to speed up calculations. Carry select adders pre-calculate sums for both carry-in values. Each adder type balances speed, complexity, and cost. Choosing the right adder is like picking the right tool for the job. Real-world applications adders everywhere. So where do we find these mighty adders in the real world? The answer is pretty much everywhere. They're the backbone of countless electronic devices and systems. Your computer's CPU uses adders for everything from basic arithmetic to complex calculations in games and simulations. The graphics card relies on adders to render images and videos smoothly. Even your smartphone uses adders for everything from processing audio to running apps. Beyond computers, adders are crucial in telecommunications, networking, and data centers. They're used in routers, switches, and modems to process data packets and ensure smooth communication. In the world of finance, adders are used in ATMs, point-of-sale terminals, and high-frequency trading systems where speed and accuracy are paramount. They're also essential in scientific research, medical imaging, and engineering applications that involve complex calculations and data analysis. The next time you're using your computer, playing a video game, or even just making a phone call, remember the humble adder. It's working tirelessly behind the scenes, making the digital world possible. The future of adders, faster and more efficient. As technology evolves, the demand for faster and more efficient adders continues to grow. Researchers and engineers are constantly working on new designs and techniques to push the boundaries of adder performance. One area of focus is reducing power consumption. As we pack more and more transistors onto chips, power efficiency becomes critical. Low-power adders are essential for mobile devices, wearable technology, and energy-efficient computing. Another area of innovation is exploring new materials and fabrication techniques. Researchers are experimenting with nanotechnology, quantum computing, and other cutting-edge technologies to create faster, denser, and more powerful adders. The future of adders is full of exciting possibilities. As we continue to innovate and push the limits of technology, adders will play an even more critical role in shaping the digital world of tomorrow. And who knows, maybe one day we'll have adders so fast and efficient that they'll make even the most demanding calculations seem like child's play. Please subscribe.